here is first take care of this negative right here. We would have to distribute that in because this entire thing is being subtracted. So the proper way, the best way to think about that is distribute that into all of those signs. So this
Okay, so like,
so just flip every sign. So that becomes a positive, that becomes a negative, that becomes a positive, and that becomes a positive.
okay.
Okay. And now you're just adding like terms. So there's an x cubed term here. What's 2x cubes plus 6x cubes?
8x cubed.
Exactly. And then there's a negative x squared and another negative x squared. What's negative x minus x squared? Sorry, negative x squared minus x squared.
They cancel.
No, they don't because they're both negative. What's
Oh,
negative?
I was adding. It's negative 2x squared.
Yeah, so make sure you're looking at those signs and you're really careful. Negative 2x squared. What's negative 2x plus 8x?
6x.
It would be a positive, good, 6x, and then plus 1 is the last term. So there's your simplified expression.
So I just,
Sorry.
that's only for subtraction, right? If it was addition, I just add it. But for subtraction, I switch all the symbols.
Yep. Subtraction, you switch all the symbols in the one that's being subtracted, not the first one.
Yeah. Okay.
Think of it as distributing the negative.
All right, I got it.
Distributing it like a negative one. All right, so this one, they want you to expand it. So there's a couple ways you can do this. You probably haven't learned that Pascal's triangle, so I won't confuse you with it, or if you want, I will. But basically what this is x minus 4 times x minus 4 times x minus 4.
Mm-hmm.
So to multiply this out, or to expand it, you're going to have to take this and distribute it into here, and take this and distribute it into here. And then what you get left over, you're going to have to distribute into this one as well.
Okay.
So let's just do that one at a time. Okay. So I'll color code it here. So this times this is x squared. This times this is negative 4x. Negative 4 times x is also negative 4x. And negative 4 times negative 4 is positive 16.
Okay.
Got it?
Yeah.
So that simplifies to x squared minus, notice those are like terms. What's negative 4x minus 4x?
Negative 8x.
Negative 8x plus 16. But then we still have this other x minus 4 that we haven't distributed in yet. So now we do that same thing again. We take x squared and multiply it here. And that's x. What's x squared times x?
X cubed.
Perfect. Good. Then you take this and multiply it here.
Negative 4x squared.
Good. Then you take this one and multiply it here.
Negative 8x squared.
Good. And then you take this and multiply it here.
That'd be 32.
Positive 32x. Good. And then you take this 16 and multiply it here.
16x.
And then finally, you take the 16 and multiply it by the negative 4.
Negative 64.
Negative 64. Now you add all your like terms.
Okay, so it'd be x cubed minus 12x squared plus 48x minus 64.
Perfect. All right, now you want me to show you the cool trick way to do this?
Yeah.
All right, your teacher probably isn't going to show this to you, but it's actually one of the coolest math tricks I've ever seen, and it involves something called Pascal's triangle. Okay, so here's Pascal's triangle. You take 1, you make a triangle, and you always start with 1 and end with 1. Start with 1 and end with 1. Start with 1 and end with 1. In the middle, what you do to make the next number is you add the 2 numbers above it. So what's 1 plus 1?
2.
2. What's 1 plus 2?
3.
3. And what's 1 plus 2 here?
3.
3. what's, and again, start with 1 and end with 1. What's the next number going to be?
4.
And the next number?
5.
Not 5.
Oh, on the right, it'd be 4 as well.
On the right, it'd be 4, but how about 3 plus 3?
Oh, 6.
6 is in the middle. Okay, so this is called Pascal's triangle, and you can keep going. You can make it as big as you want. But basically what you're going to do is you're going to look for this number right here, that 3, the exponent. That's the level that you're going to look at. You're going to use this level.
Okay.
So this number right here, these numbers are what you're going to put into your equation. So what you're going to do is you're going to take, so this right here, x, and this right here is -4. You're going to start with an x cubed and a -4 to the 0 power. And then you're going to keep decreasing this by 1 and increasing this by 1. So watch, I'm going to do this at the bottom, okay? So watch down here. I start with x cubed, and I start with -4 to the 0, and then I make it x squared and -4 to the 1, and then I go x to the first and -4 to what?
Second.
Good. Then I go to x to the 0 and -4
to the third.
Cubed. Okay. Now you take these numbers in the Pascal's triangle and you put them in front. 1, 3, 3, 1. That's literally all you do. 1, 3, 3, 1. And then you just simplify and do the math. So this right here simplifies. Anything to the 0 power is just 1, right? So that's just gone. So you get x cubed.
Yeah.
This is -4 times 3, which is what?
-12.
-12 x squared. Do you see that?
Yeah.
This is 16 times 3, 48 x. This, anything to the 0 is just 1, right? So that's just gone. X to the first, x to the 0 is just gone. And what's -4 cubed?
64. -64.
-64. So you would actually get that. You did that.
So if the exponent was like 4, then I would use the numbers 4, 6, and 4, right?
Yeah, exactly. So that's called binomial expansion. And that's using Pascal's triangle for binomial expansion. It's a really cool trick. Now, you don't necessarily have to do that, but if you had a big one, like if this was like to the 5th power, think about all that you would have to do. You'd have to keep, like, how many mistakes you could make by doing this here, right? If you understand Pascal's triangle, it's really not that hard to do.
Okay. Yeah, it seems a lot more neat.
Yeah, it's a neater way to do it. And if you understand it, it's really nice. All right, so this one says identify the degree, type, and leading coefficient. Is that what it says?
I think that was the one above it. I think this one's just
solve it. Do they want you to solve? Okay. So when we're solving this, so now what we're going to have to do, you always have to set it equal to 0, so you can use the 0 product property. So you did that well. But now the trick here is to try to turn, see how this is a cubic?
Yeah.
Cubic, you don't, like if it was a quadratic, you could try to factor it, or you could use a quadratic formula. There's all kinds of things you do. But for a cubic, you're going to have to try to find one of the zeros first, one of the x-intercepts, and then turn this into a quadratic, or you're going to have to try to factor it somehow.
Okay.
The first thing you should do when you see a four terms like this in a cubic is try to factor by grouping. So group the first two and group the last two and see if you can factor something out and if you get lucky. So if I take an x squared out of these two, what am I going to be left with?
X minus 5.
Yep. And what can I take out of this one?
You could take a 2.
And what will you be left with if you take a 2 out?
X minus 5.
And that is why you do this, because now you got lucky. Do you see how they both have the same factor?
Mm-hmm.
So you can take that out. So I'm taking an x minus 5 out, and I've got inside I've got what's going to be left here if I take an x minus 5 out.
X squared.
And what's going to be left here if I take an x minus 5 out?
2 plus 2.
Positive 2. And so now I can solve this equation. Because now I have two factors, and if something times something else equals 0, either this can equal 0 or this can equal 0. And either way, I'll get 0. So either this is the zero product, or the zero product property. X minus 5 equals 0, in which case x equals 5. So there's one of your answers. Or x squared plus 2 equals 0, in which case x squared equals negative 2. Uh-oh. Have you learned about imaginary numbers yet?
Mm-hmm.
You have. So do they want you to solve this over the complex numbers, including imaginary solutions?
Yeah, I think they do.
No problem. So then x would equal, if I take the square root of this, it's plus or minus I square root of 2.
Oh, okay.
That makes sense?
Yeah. So every time it's x squared, it's going to be plus or minus, right? Or every time there's a square root, it's going to be plus or minus.
Not every time there's a square root, but anytime you are introducing it into the problem, like here, if you're solving this equation, you're getting rid of the squared. If you're taking the square root, you have to put a plus or minus in front of it.
Okay. Yeah.
Because think about it. If you said that x squared equals 9, what are the possible answers for that?
3 and 3, negative 3, negative 3.
Right. Negative 3 times negative 3 also works. So when you take the square root, you don't just write 3. You have to write plus or minus. There's two answers for that equation.
Okay. Yeah.
Positive and a negative square root. That would work.
All right.
So the next one says solve. Oh, this one's fun. So if we have x cubed plus 27 equals 0. Do you remember the trick, the SOAP trick? Did we talk about this last time?
Kind of.
So here's the SOAP rule. I'm going to write these down on the bottom. If you have a cubed plus b cubed, that can factor into, look what I'm doing here. Same sign, opposite sign, always positive.
Yeah.
So the same sign as what you have is a positive, and so this would be a negative. And now all you do is you take a and b and put them here. Take a squared and b squared, put them here. Take a times b and put it here.
Okay.
So if it's a cubed minus b cubed, that also works. But the same sign now would be a negative. The opposite would be a positive and always positive. So ab, a squared, ab, b squared.
All right.
So what do I have here? I have an x squared, a cubed rather, and I have a 3 cubed, right?
Mm-hmm.
So how do I factor that?
It would be
same, opposite, always positive. What do I put here? What do I put here and here?
It would be 1 and 3. Or x and 3.
3. Mm-hmm. What do I put here?
X squared.
Mm-hmm.
3x.
Mm-hmm.
And then 9.
Perfect. Good job. Equals 0.
Mm-hmm.
Right? And now what can I do? Remember, just like I did before, the zero product property says this times this equals 0. That means either this equals 0 or this equals 0. So I write two equations. X plus 3 equals 0, or x squared minus 3x plus 9 equals 0. In this case, to the left, x equals what?
Negative 3.
Good. And to the right, ooh, that doesn't factor. How do I solve that?
Quadratic formula.
Perfect. Good job. So x equals negative b plus or minus. You see the 2? There's the plus or minus. That's where you get two answers.
Yeah.
The square root of b squared. What's b squared?
9.
Minus 4ac. 4a, what's c?
9.
Good. All over 2a.
2a, yeah.
Which equals 3 plus or minus the square root of, let's do this in our head. What is that? 36. 9 minus 36 is negative 27.
Yeah.
Negative 27 all over 2. Ooh. Hey, 27 is a perfect square. Actually, I'm sorry, it's not a perfect square, it's a perfect cube, but that's a square root. So simplifying this is going to be, notice it's also got a negative, so it's going to be I, right?
Yeah.
This is going to be 3 plus or minus 3i square root of 3 all over 2. Do you see how I did that?
Yeah, because 27 is a perfect cube. So
yeah, it's 9 times 3. So I took the square root of 9, which is 3, and I brought it outside. And I also took the square root of I, or the square root of -1, which is I, and I brought that outside. And then just this 3 was left in there.
okay.
So there's your answers. 2 imaginary and 1 real solution.
So I have 3 answers. Okay, yeah.
3. One real solution. This is called a real solution, and 2 imaginary solutions. In total, you have 3 complex solutions. Complex includes real and imaginary.
Okay.
Okay. It says write the following in standard form and identify the degree, the type, yada yada yada. Okay, standard form just means multiply it out.
Yeah.
So you're going to take 3x plus 2 and x squared minus 6x minus 3, and just like we did for that other one, just multiply it out. That times that is 3x cubed. That times that is, you tell me.
Negative 18x squared.
Good. That times that is
9 or -9.
negative 9x. Don't forget the x.
Yep.
2 times x squared is
2x squared.
plus, don't forget the plus 2x squared.
Yeah.
2 times -6 is
Negative 12x.
good. And then
Negative
2 times
-6.
-3 is -6. Good. Now let's add like terms. There's only 1 cubic, so it's 3x cubed. There's 2 squareds. What's negative 18x squared and 2x squared?
Negative 16x squared.
Perfect. Good. And what's negative 9x and negative 12x?
Negative 21x.
Good. And then -6. There's your answer in standard form. And don't forget the f of x equals.
Okay.
Okay, so that's just called standard form.
Yeah.
And then the degree would be cubic, quadrinomial. What are they? It says type.
Yeah, that's what they so when
Could
she
you call it
says
just a polynomial of 4th degree?
no,
sorry,
my
polynomial.
math teacher, when it says type, she wants us to put cubic, and then when it says degree, she wants us to put 3, like to the 3rd degree.
Okay, so cubic, the degree, cubic does mean degree. So I don't, type. I don't know what she means by that. I think what they probably mean, honestly, because this looks like it's in a textbook, they mean the type would be a polynomial. So it'd be a cubic polynomial. Normally type is the number of terms it has. If there was 3, like this is a binomial, this is a trinomial, but this is you can call it maybe a quadnomial, but usually you don't hear that. You just hear it just cubic polynomial.
Okay.
Well, with 4 terms, but whatever she wants, just make sure you know what she wants. And what's the leading coefficient?
3.
Good. Perfect. Good job. All right, write a polynomial function in standard form of least degree that has rational coefficients, leading coefficient of 1, and okay, so they want rational coefficients, they want a leading coefficient of 1, and they want these as the zeros. So if 6 is a 0, that means that x equals 6. So if I solve this, I'm kind of going backward. If I set that equal to 0, that would mean x minus 6 equals 0. So that's one of your factors.
Yeah.
That makes sense?
Mm-hmm.
And if 3i is a 0, then so is negative 3i. So I'm going to teach you this really cool trick. Let me try to remember how I teach it. Has your teacher explained how to do this if 3i is a 0?
Yeah, but this is like, it's like the one thing that I like completely don't understand. Like,
okay,
I don't know.
So All right, so here's the trick. X squared plus AX plus B. This is the here, let me do an example over here and I'll show you. If I had -4 and positive, let's say +6. So my zeros are, what are my zeros here?
-4, +6.
-4 and +6. If I multiply this out, I'm going to get x squared minus 2x minus 24. Do you see what this is right here? This is the opposite of the sum of the zeros.
Okay, yeah.
And you see what this is right here?
That's them multiplied together.
That's the product. Exactly. Good. Excellent. Is that what your teacher taught you?
No.
That's the best way to do it, in my opinion. So
Okay.
here's the little trick I'm going to teach you. Here's what you have to remember. That little formula right there. This is going to be the sum of zeros. And this is the product of zeros.
So the product would be like just 3i times
3i. So just do it for 2. This works for when you have 2 zeros. So do it for 3i and if 3i is one of your zeros, what's the other zero have to be?
-3i.
Exactly. So do it for 3i and -3i. What's the sum of those?
9i squared.
No. What do you, if I
Oh,
added
the sum.
yeah, if I added them,
0.
it would be 0, right? So the sum of those is 0. So let me do that right here. The sum is 0, and what's the product?
-9i squared.
It's -9i squared. And what does I squared mean? What's I squared equal to?
-1.
That's right. So what's the product really?
9.
Just +9. So do you know what the quadratic you would get from that? It would just be x squared plus 9.
Yeah.
So that's the quadratic from these 2 zeros. And now let's just add the other 0 into it, or include the other 0. What's the other one? We just did it up here, remember?
It's x minus 6.
X minus 6. So now just multiply that out. So x squared times x is x cubed. 9 times x is 9x. 6 times, well, let me do that first. -6 times x squared is -6x squared. 9 times x is 9x. 6 times 9 is 54, -54.
Yeah.
There you go.
Okay.
That's how you do that.
Yeah, that seems a lot easier because I don't remember exactly what she taught us, but it was
Let's try another one.
okay.
Let me show you another one. What if I told you that 2 was a 0 and 4 minus I was a 0? It's a little bit trickier with one like this, but it still works the same way. So what's the other 0?
4 plus I.
Good. 4 plus I is the other 0. So now let's do it with these. What's the sum of those?
0.
No, look carefully at it. What's 4 minus I plus 4 plus I? What's that equal? The i's cancel, but what's 4 plus 4?
8.
It's 8.
Oh,
and what's
okay.
the product of the zeros?
16.
Oh, you got to look at it carefully. You have to do the math. You have to do this.
Oh.
Yeah. Okay. Were you doing that? 16. And then the
Plus
-4i and +4i, those cancel out. And what's I times -I?
-I squared.
And what's I squared again?
-1.
Good. So that's really +1, right?
Yeah.
So that's 16 plus 1, which is what?
17.
So this is 17. So what's your quadratic that comes from this? It's
X plus
squared.
or X minus.
Remember, you do minus the sum with an X plus the product. That makes sense?
Yeah.
So that's the quadratic that you would get. Now multiply that by, what's the one that comes from here? What's the 0 or the factor rather that comes from this?
The factor would be x minus 2.
Perfect. Good job. You're getting this well. X minus 2. And now just distribute it out. X cubed minus 8x squared plus 17x. Now the 2, negative 2x squared, positive 16x minus 34. Add like terms. X cubed minus 10x squared plus 33. X minus 34.
Okay, and it has to be in standard form, right? Like if it's out of order, it's wrong.
Yeah, I mean, I don't know. You should put it in standard form. Yeah, you'll probably get some points taken off if you don't.
Okay.
All right, good.